Okay, so we're looking at trigonometric functions, and we're beginning by looking at trigonometric functions in right triangles. And let's first kind of identify our right triangle, or parts of our right triangle, the sides of our right triangle, I guess, to be specific. And so here we have a right triangle. And when we have a right triangle, we're going to most often see it identified as a right triangle with a little box right here. Now, the side opposite the box, the right triangle box, and this would be opposite here, is going to be the hypotenuse. Now, also often we're going to see the Greek letter theta used. So here's we got the Greek letter theta. And this would be one of the two acute angles in a right triangle. And we have, from the theta, we have an opposite side that's going in this direction. So this would be the opposite. And then we have an adjacent to the right triangle, to angle theta, excuse me. And here is the adjacent. So we got three sides of the triangle. We got the hypotenuse, which is opposite the right triangle. We have an angle measure of theta, and it could be anything, but theta is often used. You might see it A, B, could be anything. Eventually, it may even be defined as an actual angle measurement in either degrees or radians. And from that, in this case theta, we have an opposite side and we have an adjacent side. Now we can take this information to build upon the 6 trigonometric functions. And first we're going to look at the first 3, sine, cosine, and tangent, and then we'll take a look at cosecant, secant, and cotangent. Okay, so let's take a look first then at the first 3 trigonometric functions, sine, cosine, and tangent. And here again we got a right triangle, and here's our identification of which angle is the right angle with the box. And let's say that we got theta here. And because this side is opposite the right angle, this is the hypotenuse. And this side over here is opposite theta, so it is the opposite side. And this side here is adjacent to theta. We identify this as the adjacent. So we've got OHA. Now, the sine, or as we may represent, the sine of theta equals the opposite side over the hypotenuse. And the cosine of theta, which we might represent then here as the cosine of theta, is equal to the adjacent side over the hypotenuse. And the tangent, let's say the tangent of theta, is equal to the opposite side over the adjacent. Now this gives us 3 acronyms that we call SOHCAHTOA. So the sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. SOHCAHTOA. Sine is the opposite over hypotenuse, S-O-H. Cosine is the adjacent over hypotenuse, C-A-H. And the tangent is the opposite over the adjacent, TOA. SOHCAHTOA. And this helps us work our way through. Using SOHCAHTOA can help us work our way through the calculations of the 6 trigonometric functions in right triangles. SOHCAHTOA. Now, in addition to the 3 trigonometric functions that we just looked at, sine, cosine, and tangent, we also have 3 additional. We've got the cosecant, which we often see expressed as CSC. We have the secant, which we often see expressed as SEC. And we have the cotangent, or the COT. Now, the cosecant is equal to 1 over the sine. And we'll put theta. Should put theta in here probably. The secant is 1 over the cosine of theta. And the cotangent is 1 over the tangent of theta. So these 3 trigonometric functions, the cosecant, the secant, and the cotangent, are the reciprocals of sine, cosine, and tangent. So let's go back here. We're going to put a box in here, get us an identification of a right angle, and we're going to put theta here. And this, of course, means that this is the hypotenuse, this is the opposite side, this is the adjacent side. And so coming back over here to then again, what then is the cosecant? Well, if the cosecant is 1 over the sine, and using SOHCAHTOA, the sine is opposite over hypotenuse, then that would mean that the cosecant is, we could also say, is the hypotenuse over the opposite side. Now, if the secant is 1 over the cosine, and the cosine is adjacent over the hypotenuse, then the secant could also then be expressed as the hypotenuse over the adjacent. And if the tangent is opposite over adjacent, SOHCAHTOA, tangent opposite over adjacent, then the cotangent then is the adjacent over the opposite, the adjacent side over the opposite side. All right, so that gets us started with some definitions of the 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, cotangent. Or I could say the sine, which is the opposite over the hypotenuse. Therefore, the secant is 1 over the sine. The cosecant is 1 over the sine. And that would mean that the cosecant is the hypotenuse over the opposite. We've got a cosine, which is the adjacent over hypotenuse. And the secant is 1 over the cosine, which means that the secant would be the hypotenuse over the adjacent. And we've got a tangent, which is the opposite side over the adjacent side. Therefore, the cotangent, being the reciprocal of that, is 1 over the tangent of theta, which would make it the adjacent side over the opposite. So learning this SOHCAHTOA can help guide us through putting together all the trigonometric functions, which we're getting ready to work with here in just a moment. If we know 2 of the sides, we can find all of the 6 trigonometric functions. We may have to use Pythagorean theorem, a squared plus b squared equals c squared, to help complete our task.